Hello friends, welcome to Unacademy, which is the largest online education platform for GATE Computer Science. Myself, Malesham Devasane, I'm going to take on this channel theory of computation, compiler design and C programming. And thank you for waiting. And in this session, I'll be teaching a very important session, which is syntax directed translation. Okay, let's introduce myself before starting the session. And I have secured all rank 119 and 210 in GATE exam during my BTech, and I have completed MTech from IIT Bombay. Then I started taking the GATE classes. Then here I have almost now many of the subjects I have taken so far. Among them, I am taking TOC, compiler and programming. So this is my referral code DEVALIVE. If you are going to use DEVALIVE referral code, you will get 10% discount. But DEVALIVE doesn't mean that you are only learning from me. It is an entry to Unacademy. Remember that. So you will be learning from every educator on Unacademy. So that is the most beneficial things from Unacademy subscription. So you can use for Plus and Iconic subscription. The Plus, you will have live classes, and Iconic, you will have a separate coach. You will have a personal coach to guide you one-to-one. And then you will have a study plan, study booster session, personalized test analysis, and separate study material. So if you look at my profile, you will have more than 350 classes which will help you to learn something freely. These are completely free classes, guys. So it's just like, more than 350 classes, in the sense you will have most of the concepts are covered from many subjects, including TOC, compiler and C programming. We will also have a mixed questions practice in my sessions. So you will have a practice sessions, revision sessions and regular classes. But these sessions is only for 1 hour every time. So 350 classes, you can assume that will be equivalent to 350 hours. Yeah. So we have the Plus courses which are paid, and this is about a different criteria compared to free classes. Here we will have the complete course. They're all complete and well structured courses where you will learn every concept of the subject in structured manner, and we'll have a weekly test, we'll have a doubt clearing sessions and so many benefits from your Plus courses. So I have already taken TOC, compiler, C programming, and again I'm going to start soon the fast track course on TOC soon. And the benefits of Plus Iconic subscription, that structured courses, and each subject you will have n number of courses from n number of educators, and that is the most beneficial advantage that from the Plus subscription. And you can learn maximum thing from Unacademy. You will have a separate batches to rank improvement, long term, short term. You can attend all of them, or you can attend any one of them that you require. Okay, so if you are going for Iconic plans, that you have you will have separate, as I said, all of them dedicated codes, separate study plan. These are the additional benefits. So Iconic is more beneficial than Plus, but if you are only interested for the Plus, that's welcome. Yeah. And every plan here is having a special requirement, like if you have 2 months plan, you can go for 3 month subscription if you don't have much time before the exam, but you are preparing from second year, third year, and you are looking for long term at least 1 year, then choose these plans: 1 year, 1.5 year, 2 years. And you can see the Plus plans. These are all Plus plans which are very popular: 27,225 for 1 year, 39,600 for 2 years. And in Iconic you have, as I said, more advantages. And 1 year, that's the reason you have 40,500, and for 2 years you have 54,000 you have. And this is my referral code to get the subscription, guys. And you have very good educators on this platform, like operating system Khalil sir, and data structure and CO by Vishwadip sir, and me, C programming, TOC and compiler, and Satish sir, discrete mathematics and DBMS, and similarly Pankaj sir for CN, Compute Networks, Pankaj sir, and digital Arun sir, and mathematics Pallav sir. So we have every subject. We have every subject, and we have very good faculty on this platform. So try to learn every subject from this channel and from our top educators. And please like this session so that we can begin our session, which is very important for us. Yeah, guys. Now, what we have seen in the previous compiler design, that is lexical analysis and syntax analysis. So what is the lexical analysis, syntax analysis? We have seen already, right? Now we will have a very good plan, that is today syntax directed translation. So what we are going to learn? We are going to learn various different terms like what is syntax directed translation, why, when we call translation scheme, and when we call evaluation order, and when do you require that, and attributes, what kinds of attributes we are going to deal, and what kind of definitions we are going to use, or the evaluation techniques we are going to use here. So these all techniques we are going to understand. Yeah, if you are going for any entrance exam like ISRO, BAR, Triple IT Hyderabad, any competitive exam, these lectures are for you, even including semester, because we are teaching content and that is required for the subject. And if you are learning the right content from the right place, then you are going to eligible for any exam. Remember, if you want compiler design for any kind of exam, learn the compiler design right way. So you will be eligible for all. So compiler design for semester different, compiler design for exam different, competitive exams not like that. The content everywhere same. The way you present, the way you apply may be different, but the content in different places will be also same, right? All right, Vaishnav, good evening, and Satyajit, good evening. Sandeep, good evening. Yeah, it will be eligible for all. Good. And if you are watching this video, please like the session. Let's begin today's session, guys. What is SDT? Why we use SDT and where will be applicable? That's we are going to start slowly. Here, I'm going to use a very important term, that is attribute grammar, or you can call attributed grammar. What is attribute grammar? We are going to learn slowly. And what is translation scheme? And when you are using these two words for two different purposes. Attribute grammar is to understand specification, right? What kind of semantic you are using in the grammar and how the symbols of the grammar are related one with other. So this is about a definition of the grammar, basically definition. So what kind of definitions we are going to use for the grammar? That's one. And what is translation scheme? That is going to be, it is going to help you to understand whole SDT, that is basically used for implementation. It's going to help us to understand how do we evaluate, and it also helps us how to understand the given grammar with the help of this translation scheme. So translation scheme, when we say we have the grammar, maybe you will have along with attributes, doesn't matter, and where actually this semantic is placed. You have the semantic actions, and where are these semantic actions placed in the production. So translation scheme is going to talk about the place of the translation and how we are going to evaluate. So basically for use for implementation. Yeah. All right. So I'm going to talk about what is the SDT. It's not over. What is SDT? Let me talk about before doing this. It's SDT is like, you have a context-free grammar in which you have the semantic, like we call them as translations. Translations you can call as a semantics, or you can call rules, separate rules, or you can call it as a program. So CFG along with translations is called as an SDT. But to understand SDT, you should know about two things. What is attributed grammar? It talks about how do you write SDT, and second, how do you evaluate SDT? That depends on translation scheme, right? Both are actually the part of the SDT. What is the given SDT and how do you evaluate SDT? So both are going to understood by the attribute grammar and translation scheme. Slowly we'll come to that. Okay, so in this SDT, I said attribute grammar. When we are talking about attribute grammar, grammars are associated with grammar. Attributes are associated with grammar symbol. Example, see here, capital E, capital L. These are actually grammar symbols. But what is VAL? VAL is attribute. So these attributes are associated with your grammar symbol. Here you can see lex value. This is another attribute. And this attribute will talk about the property of the symbols, how we are going to depend and how we are going to compute. Everything is going to be related in this SDT. But attribute grammar, when we say the attributes are associated with the grammar symbols, so that during evaluation we can understand how these are going to be used, right? But they are evaluated by semantic rules, not now. Rules will decide how to understand them. When you go for translation scheme, then these semantic rules are going to be placed somewhere in the grammar, somewhere in the production. So that is called as a translation. So translation will help us where is the position of each semantic rule, how these are embedded in the right side of the production. So it's going to help us for evaluation. If you want to evaluate this translation, you will require the scheme. What kind of scheme you are using, and that what kind of scheme doesn't mean it means where is the position of the semantic rule. Okay, attribute grammar talks about how the attribute basically called as a property here. You might be talking about value, or you might be talking about name or constant, or anything about some meaning. Attributes are associated with the grammar symbol. Okay, clearly we'll come to slowly, guys. Clearly, here two things are there. Attribute grammar, it means we have attributes to understand how the symbols are related in the grammar. And translation scheme, nothing but this. We have a semantic rule. In the semantic rule, attributes are specified maybe, and the semantic rules are going to be placed as a part of the production. Then we call it as a translation scheme. Yeah. Now attribute, I am clearly mentioning this is your symbol, right? This is your symbol of grammar. And when you say dot, let's say VAL, so you might be looking for value attribute, right? This is your property of the symbol. This is about attribute. What you are going to do with this attribute? So VAL talks about the property, so we call it as attribute. Attributes are used to understand the property type. Some people use the clear name, or some people use good question. Look at guys, E dot X, E dot yes, E dot type, E dot value, E dot count. Doesn't everywhere the symbol is A, E symbol is E is a symbol, but here X is attribute, S is attribute, and type is attribute. These are the different attributes, but it depends on your requirement how to treat attribute, right? Sometimes attributes will specify like count, value, type. You will get meaning of that attribute. But sometimes X, Y, Z, S, I, J, that you should understand why are you using that names. Okay, it's just a property that you are gonna do in the grammar. So we don't care right now. We are not worried about much what kind of attributes we are using, right? What kind of symbols we are using in the grammar. Yeah, good evening, Sweta. So we have, when we are specifying the semantic action, whenever you are writing some semantic action like, E dot X is equal to, let's say, ID dot num. Here, what do you have? This is called as a translation. And here attributes are X and num. Both are attributes. They are defined on some symbol like capital E, and ID is also symbol. So E and ID are symbols of the grammar. Symbols of given CFG. Right? Everybody? So you should not have a doubt on what is attribute, what is symbol, what is translation, because semantic rules depends on these three things: symbols, the semantic rule. We call here semantic rule. You may call it as a translation. Simply, the name is a translation. Semantic rule depends on your symbols of the grammar, whether it is terminal or non-terminal doesn't matter, and also attributes that we are going to use, and also the whole translation, that is a complete translation, that you can say that it's a meaning. The translation has everything. That translation itself is called a semantic rule, in which both symbol and attributes are there. Yeah. Fine. So we'll come to that point. Don't worry, it's just beginning. What is table? I don't understand. All right. ESDT basically can be used for many purposes. Like, you can update your symbol table, add the types, and you can check the types in the given expression, and you can produce error message if you don't have the proper semantic of the statement program. You can generate intermediate code for the given program, and you can generate parse tree for the given program, and any purpose. When you have a meaning, then definitely SDT can be used. All right. And as I said, attribute. What is attribute? Attribute may contain any information, like you have a type, string, number, address, memory location, or any data that you want to handle in the syntax, then you can use the attributes. So attributes are going to get the meaning from your syntax, right? You might be written sometimes like, id1 is equal to id2 plus id3. But the internal meaning of this one may be, x is equal to y plus z. Then it will take x is equal to y plus z. It will display for you. If id1 is x, id2 is y, id3 is z, maybe you want to write x is equal to y plus z. So that can be produced with the help of SDT. Non-terminals is not a table. Non-terminal is not a table. Non-terminal is internal symbol. It's a representation. It's a symbol to derive our syntax basically. Non-terminals are internal to the compiler. They are not visible to the programmers. Programmer writes only the program, and the grammar internal to the compiler is going to understand what is your program, how, whether you have written the syntax correctly or not. Yes, Pratiksha, good evening. Okay, attributes. What is attribute? As I said, when we are talking about SDT, we have a context-free grammar plus semantic rules. And these semantic rules are attributes inside. That's why we call that grammar is attributed grammar. Anyhow, attributes are specified inside the semantic rules, or any rule that you want to specify. And here we have two types of attributes. One is inherited attribute. What is inherited? And second one is synthesized attribute. And we may not use as it is in our grammars. Remember that in our grammars we may modify these definitions. We will use them, right? And what is inherited attribute? I'm going to talk about that. So we have some examples. Before that, let me explain what is inherited attribute. Okay, here I have a question. For you guys. Suppose you are writing S derives AAB. What is the meaning of this production? Here it actually looks like a tree for us all the time. This is called as a production tree. This is called as a production rule simply. And when we are writing a production, we have much information inside, like S is a parent of capital A, small a and capital B, and capital A is a child of S. Not just that, A is also a sibling, is a right sibling to small a and B, and small a is a right sibling to capital A, because it's their right side, and it is left sibling to capital B, and A is the child of S. And similarly, capital B is the right sibling to both capital A and small a, and it is the child of S. Yes, we have this much of information in every production. So when we are talking about SDT, then this information should be gathered. Now let's talk, sorry, not this one. Let's talk about this inherited attribute. And also one more point, very less people know about that. Guys, S derives AAB. And when we are saying A dot X is equal to S dot X plus, let's say, 2. And if you say that, here you need to understand computation is happening at A. Depends on its parent. This is how we should read. So LHS is also called as its definition. Computation is happening here. That S we are not computing. The computation is happening at capital A. So that depends on S. It means the computation depends on parent. Depends on parent. Everyone, depends on parent. So computation at A is going to depend on parent. So this kind of information is required. Are you depending on parent or child or sibling? That information is very important for us now. In case if you are writing B dot Y, there is another attribute Y that might be depending on A dot Y multiply with S dot Y. Then what is happening, guys? Here B, we are computing at B that depending on left sibling and also parent. So computation depends on left sibling and parent. This is how we speak the computation at capital B. Clear this point, guys? Look at this definition. If we ignore, then you might confuse about SDT completely. So now I am going to use the definition of this inherited attribute. The computation depends on at any node depends on parent or sibling. It could be left sibling or right sibling, that grammar will decide. But in general, inherited attribute definition, that is nothing but computation depends on parent or sibling. And mostly we use only left sibling. Why? I will talk about that later. And synthesized attribute, the computation depends on children. When the computation depends on children, you can call that attribute is synthesized attribute. You can call it as synthesized attribute. Now let's look at and practice these two attributes in the grammar. Now first find out how many attributes are there, guys. VAL and LEX VAL, and we are only computing VAL. Look at that, everywhere VAL only computed because that is left side. So we have two attributes. Among them only which is computed is VAL is computed all the time. Lex value is already exist. VAL only computed, nobody else. Now you have to look at, is this VAL following inherited or synthesized? So for that you should have a tree knowledge. Who is the parent, who is the children, who is the sibling? Yeah, alright. Now let's talk about L. This is L and depending on its children, right? You are computing L at L by depending on its child, So right now it looks like you are following synthesized. And now next, E. We are computing E by depending on its children. Again, same concept. And is that true for everyone? Look at that. T we are computing. T1 and F both we are using in T. And same. So this is value is synthesized. Attribute. How do you know that? Because in every production it uses the child computation, it uses child values. Yeah, clear this point? And this is one kind of question where you require to understand. Even this one also, F also using digit, but digit dot lex value. Okay, next example 2. Now some people have no idea about SDT. That is the reason they don't understand this information. This information is not for computation, is to take some action and do something in the table. So please don't look at such things. They are functions. They are functions, guys. They are functions. Okay. So here computation is not happening at all. So I can delete that. But now look at it. C we are storing in T. So we are storing at T. So computation at T depends on children, and computation at C depends on its right sibling. Is it clear? So now how can I say that here how many attributes are there? T is there, B is there, and that's all value. These are the attributes. Now what are looking at? Any of value is not computed. Only we are computing here T and B. T and B. You can see that T, B, T, T, B, T. So we are computing only T and B. So now focus only on one attribute rather than both. So I am focusing on first T. So I will look at what is T. That's all. So don't look at the B now. Don't look at the B now. Only look at the T. T, 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 and T. Now look at here looks like synthesized because it's depending on child. Integer is stored in T, that's fine, and float also, and num dot value or C1 dot T. The both are children of C, so both are used as like synthesized. And T is equal to C dot T is equal to C dot B, and C is itself, right? Itself is fine. So T is synthesized. How do I understood? It always depends on the children, or it will not depend on anybody else, or depends on itself is okay. Synthesized attribute. And they may ask what is the T, what is the B, what is the value. Then you should say T is synthesized, guys. And similarly you have a B. What is the B? Now focus completely on B, and B means this one and this one. That's all. This will decide the answer. And here you depend on the B. Actually B is the left sibling, so that doesn't come in as synthesized. That can come under inherited. And C1 dot B is equal to this one. We are computing by looking at the parent. So here B is inherited. Clear this point? Yeah. Come on, guys. B is inherited. That's example 2. So T is synthesized, B is inherited. Now next one. How many attributes are there? Type is there and entry is there. Look at dot, after dot, who is there? Type and entry. And entry we have not calculated any time. So only type you have to do. Only type we have to do. And x1 dot type is equal to x2 dot type. So here x1, x2, x3, x4 actually not mentioned it. I have taken from the previous ESE GATE question. So if I do something there, you will understand. So I am writing something, guys. Don't worry much. Okay, I'm using my own terminology, guys. My own terminology. So here add type is actually the functions. So we can delete them. Nothing is happening except the entry into the symbol table. Now look at how do they calculate. T1 dot type you are calculating. That means this is calculated based on its parent. So it's nothing but guys, what is it? It's an inherited attribute in this production. And T we are calculating based on its children. And both are type, guys. Type one time we are using parent, one time using its children. So this type is not going to be anybody now. Type is neither inherited nor synthesized. If you say inherited, then everywhere it should be inherited. If you say synthesized, everywhere it should be synthesized. When you say both, everywhere it should be both. Type is neither inherited nor synthesized. Anyhow, other attributes are not calculated in this grammar. So how do we say in the first production type is following inherited definition, and second production it is following synthesized definition. That's why type is not going to be anyone. Okay, this is a definition of the attributes, guys. Okay, that's attributes. Now attributed grammar. Attributed grammar is nothing but it is syntax direct definition, and definition we are going to talk about. When somebody using attributed grammar, we will add some definition inside that SDT. So where the semantic rules cannot have the side effects. So you will understand in that semantic rule, using attributes, what kind of relation exists between the symbols of the grammar. We have two types of attributed grammar definitions, LAttributed and SAttributed grammar definition. So what is LAttributed? In the LAttributed, the computation at any node depends on parent, or in inherited it is any sibling, but here we use left sibling only, or you can use children, and it is a hybrid combination of inherited and synthesized, right? Computation depends on, and that semantic rule translation, that semantic rule can be placed anywhere in the arches. Okay, these are the 2 points you have to remember about LAttributed grammar. Computation depends on parent or left sibling or children. Example, when you add A derives PC. So I can have like, C dot x is equal to A dot x plus B dot x. It's okay. This is gonna be the LAttributed grammar, because x is an attribute. The x is an attribute that is computed based on its parent or its left sibling or AND. So this is called as the LAttributed grammar. LAttributed grammar, guys. Clear this point? Yeah. When you don't have any kind of dependency, you don't need to depend on anybody. You can have also empty rule. Yeah. Come on, guys. Keep chatting. Your interaction is more important to me. Or I can use something A dot y is equal to B dot y plus 1. Here, this is also fine. Why, guys? Because the A is depending on its children. That can be done. Children you can depend, or you can depend on parent, or you can depend on sibling. All the concepts are there. But always use the left sibling to calculate. Okay, another one, SAttributed grammar, which is very easy. Attribute computed, computation depends on, based on its siblings, its children, depends on children. Example, you have E derives E1 plus E2, and rules, the semantic rules must be only at the end. End of production. So now you can write here E dot x is equal to E1 dot x plus E2 dot x. Then what happened here? This computation at E depends on its children, right? This kind of grammar is called as SAttributed grammar, guys. Now we have an example to understand which grammar it is, right? So value that you are computing it here by depending on its children, so that's fine. You are computing it here and by depending on its children, that's fine. Synthesized up tak. E derives T, yes, synthesized. T derives T1 dot F, synthesized. So here a value is synthesized. So what we say, this whole grammar is SDT is S attributed grammar. And only one thing is missing, that is the where did you place this production. So I am assuming all the productions are at the end. If you place these productions are anywhere other than at end, then what happens, guys? It will not S attributed grammar. S attributed grammar will be only at the end. So which is very important, guys. All the translations must be at the end and you must be computing based on its children. So here everybody depending on its children. So I can say grammar is S attributed grammar. Then so every S attributed grammar is L attributed. You should remember this point too. Here I no need to say L attributed, but every S attributed is L attributed grammar. By definition. Yeah. Is that clear? Equal. Okay, now it's fine, I think. Okay. This grammar is S attributed, so L attributed. Now next one. And do not look at this add type. I'm just leaving this a symbol entry, a symbol table entry, guys. Now look at how do you calculate. This is a function. So functions no need to look at. This one you have a T and B. So T and B both you should understand what they are doing. T. So let's look at here. T. T dot T. We are computing based on its children. Okay. C dot B is based on its sibling. So one is following sibling, other is following our children. So another one B. It depends depending on its children, depending on its child, depending on its child, depending on its child. So only this one is different. Looks like, right? Yeah. So remaining all depending on children. So T is no doubt is depending on children. So it is synthesized attribute. Attribute only, not a grammar I am talking about. Attribute. And B, when you look at a B, you are following left sibling. So it is inherited attribute. No problem at all. Now look at the grammar. Now grammar, what kind of grammar it is? S attributed or L attributed? If it is S attributed, every attribute has to be synthesized, guys, because it depends on children. Did I write that? Right? It depends on its children. It depends on its children. Okay. So now if you look at both, the B depends on its left sibling. Because of that reason, some attribute computations are depending on parent or left sibling or children. Then we say grammar is L attributed. Here it is not S attributed. But not S attributed. Okay, but not S attributed. Example 3, we have you can assume that T here and T here, and this is L1 and I'm using this is L. L dot type and L dot type. That's okay. That's okay. Okay, now let's look at what kind of grammar it is. Is it S attributed? Now here look at, you are computing at this place by depending on its parent, and here you are computing here by depending on its children, and this one you are computing at L1 by depending on its parent or children, guys. That is inherited attribute. So you can use that. It is L attributed grammar. And I'm assuming all the translations are only at the end. L attributed grammar. And when you place semantic actions in the productions, then we call it as a translation scheme. अब तक तो मैं translation scheme नहीं दिखा रहा हूँ आपको, सिर्फ productions and semantic action. Okay, all right. Now we have, as I told that you have plus and iconic plans. Plus means you have live classes. Iconic means you have a personal coach, study planner and study booster and personalized test and preparation study material guys. And if you are coming to the regular and plus courses, and you will enjoy a lot in every detail, because here the number of hours is not limited in plus courses. So we will elaborate each and every point till the understanding. And you can follow me on Unacademy, that is unacademy.com/devagate guys. So now we have two evaluation techniques. Looks like I may not complete today this one. Dot, okay. Here t dot type is equal int. आप बताओ ये क्या बनना है? आप बताओ ये क्या है? T derives int. T कौन है? You are computing. Here computation is happening here. You are computing here by depending on, because this is LHS is a computation. Remember, LHS is called as a computation. That computation depends on whom? That computation depends on child. Computing here by depending on child. तो इसको क्या बोले आप बताओ? आप बताओ. Inherited में inherited you can depend on parent or sibling, and synthesized only depending on child. Depending on child. But ये तो क्या है? Right? The type here sometimes depends on child, sometimes depends on sibling. Here it is a sibling, t dot parent, right? Not sibling, parent. So here depends on parent, depends on child. Who can depend on parent or child? Parent or child, वो तो attribute का नाम नहीं है, but एक definition का नाम है. Attribute का नाम नहीं है. You can't say type. Please don't say type is inherited and synthesized. Type is neither inherited nor synthesized. Type has no name, but type can be used. Type can be used in LAttributed definition, because in LAttributed grammar I use a hybrid model of inherited and synthesized concept. Yeah, this is a synthesized, but when you look at whole grammar, in this line the type is computed based on its parent, right? T is based on its parent. Here it looks like inherited, here looks like synthesized, but both concepts I have inside LAttributed definition. So grammar I am talking about, this grammar is LAttributed grammar. I am saying it is LAttributed grammar. Everyone, I am saying this is LAttributed but not SDT. Fine. And guys, we have main thing is let me talk about this. SDTs mainly depends on definition and actions. I can say that definition has something like attributed grammar. If you have any attributes, then you must specify, is it LAttributed or SAttributed. ये अब तक evaluation start नहीं हुआ, सिर्फ specifications. This will basically for specification. Specification in the sense how the attributes are related between the symbols, and one symbol depends on another symbol, how attributes are defined, and the rules, that semantic rules are placed in which part of the production or in which place of the production. And another one is translation, that is I can talk about, this is evaluation order, evaluation order. This evaluation order depends on translation scheme. When you are talking about translation scheme, that depends on the evaluation order. It's basically for implementation. It just talks about functionality of the SDT. So functionality of SDT. what kind of function it is going to do. Is it going to make an entry into the symbol table, or is going to check the type of expression, or it is going to find the value of is it going to evaluate the expression value, and is it converting from binary to decimal, or is it constructing syntax tree, or is it constructing parse tree, is it producing 3 address code. And SDT purpose could be anything. The functionality can be understood by the evaluation order. So that evaluation order depends on translation scheme. Translation scheme depends on the attributed grammar. All are one related with other guys. Okay. Yes. So we have two concepts here. Yes. All LAttributed grammars are here, and these are the SAttributed grammars. SAttributed grammars. This class is subset of LAttributed class. These are LAttributed grammars. Every LAttributed grammar need not be SAttributed, but every SAttributed grammar is LAttributed. Every SAttributed grammar is LAttributed, guys. Okay. And there is a lot to learn about this one. So first have a clarity what is attribute, and what is attributed grammar, and what is the translation schema. That I am going to have make a clarity at the end of this concept. But so far we have clearly the specification oriented. That means what attribute I am using and where that semantic rule I am going to place. That depends on the type of definition. LAttributed grammar, then attributes computation depends on parent or left sibling or children. And if it is SAttributed grammar, computation depends on just children. And the position of the semantic in LAttributed grammar anywhere, but in SAttributed grammar it's just only at the end of the production. So these are the rules we have learned. And SDT evaluation, these are the implementation. I am talking about translation scheme. Implementation dependent. Like SDT with attributes, we can use LAttributed, SAttributed, both evaluations we are going to learn, but without attributes, any order can be followed in the world. There is no particular definition for when SDT has no attribute. Remember that we are going to use two things here. SDT with attributes, SDT without attributes. When you have with attributes, we will call them as attributed grammars. When you don't have attributes, just we can call simply it's a translation scheme. That's all. So anyhow, tomorrow in the next session I am going to talk about the few things: evaluation of attributed grammars, evaluation of a grammar without attributes. So these two things I am going to cover tomorrow. And today I hope you understood just words only, guys. What is attribute, and focus on what is attribute. This attribute can be like, I may use for finding the types, or finding the length, or finding the count, or finding the value, or finding anything, even name, anything. There is no restriction. That's attribute. And what is attributed grammar? Here every symbol associated with certain attributes. Then here in every production we are going to use attributes to understand each production. So here attributes are specified with the symbols. Here attributes are associated with the symbol. Attributes are associated with symbols of production. With symbols. So in grammar, we will see that attributes are associated with the symbols. And what is this translation scheme? Translation scheme. And translation scheme, nothing but we have placed this semantic rule. And when we are writing this one, is called as a semantic rule. And semantic rule is placed somewhere in the RHS. Then all grammar looks like somewhere in production of grammar. Then such grammar is called as translation scheme. And this SDTs can have attributes or may not have attributes. Then we need to understand how to evaluate the SDT that we are going to see tomorrow. And we have also learned the attribute grammar is two types, LAttributed and SAttributed. So tomorrow I'm going to talk about how to evaluate the SDT. That's more important one to understand what is SDT. Guys, sorry. And please follow me on Unacademy, which is unacademy.com/DEVALIVE, and this is my our Telegram channel, Unacademy Gate CS. You will get the links from every educator every day, so you can subscribe to this Unacademy channel. And then we have so many YouTube channels from Unacademy. Please share all these YouTube channels with your friends, and don't forget to like the session. Please like the session and share with your friends, and also subscribe. And don't forget to use the code DEVALIVE in case if you are taking the subscription. And we are there always to help you to understand